Hello once again, our most valued student. My name is Confident and welcome to the continuation of our revision session here. And this is coming from question number 3. That's where I'm taking from. This is for grade 12, of course, as you guys are preparing for your final exams. So if you are in grade 12 and you are interested in improving your marks, this will actually go a long way. So in this section, I'm going to do question number 4, which is functions. This is now on functions. I'll do question number 4 out of 18 marks, and I'll go on to do question number 5. Also, it's functions. You see that. And by the way, this is May-June 2023. So as I'm doing this, this is the latest paper. So this is on functions. This will be 14 marks. Now I've already done. I will, given time, I'll do question number 6. Also on financial maths, and then I've already done question number 7. By the way, check the previous video. I've done question number 7. I haven't done question 8, so one of the part of functions also is question number 8. I'm going to do that, as well as question number 9. I will do that, and then question number 10. So it's quite a lot that is not yet done here. Question number 10, I'll also do that as well. All right, so let's go to question number 4. But of course, guys, I've done the first question. Question 1 I've done, and question 2, sequences and series, and question number 3, as I said, this has been done. So let's look at this. Question number 4 on functions. All right, let's take our time, a little bit of time here, and work on this question. It says given function p of x is that. Is p an increasing or decreasing function? Now, what do they mean now when they're asking, is it increasing or decreasing? If I can quickly write this, they're saying p of x is equal to 1 over 3. Look at this, to the power of x. Now, if I just gave you something, let's say f of x as an example, and then I say to you, instead of 1 over 3 as a fraction, but I say 3 to the power of x. Let's say I gave you this. Now, between these two, which one is increasing, which one is decreasing? If you just take a calculator as an example, and you look at, for example, different values of x. Let me start with the first one that I just gave you, the second one, f of x. If I say 3 to the power of 2 equal to, you see the number is going up. If I say 3 to the power of 4, look at this, I'm at 81 now, the number is going up. The more I increase the power of 6, the numbers start going up. You see, as x increasing to the power of 9, you see this number keeps going up. And then let's make it to the power of 15. You see, the number gets bigger and bigger. So in brief, you are having a graph like this. This is more like a graph like this, which when you are plotting it, it will be something like this. You understand? So we call this what? This is an increasing function, because as x increases, also f of x increases. So that's where now we are going to call this one increasing function. All right, this is increasing. But now, what about if you give me this version of the graph? Let me just take this off. If you give me this one, if I take a calculator now with this p of x, and then I try to apply the same principle that I was doing here to say, let's say, as we say, 1 over 3. Now I start with power 2. I think that's what I did in the first. You see, it's 1 over 9. If you press SD, this is 0,111. Go backwards, use 4. SD, you see, 0,0 now. Go backwards, go 6 equal to, and then press SD. It's now 1 comma, this times 10 to the power negative 3, meaning it's 0,000. You see, then look at this, times 10 to the power 9. You see, SD, you see, it's 5 times 10 to the power negative 5. Yes, if I say 5 times 10 to the power negative 5, this is same as 0,00005. Because it's 1, 2, 3, 4, 5. You see, it gets smaller. Remember, it started from 0,11, but now it's 0,000. You see, this number is actually approaching if you look at it, it's actually approaching 0, you see, because it gets smaller and smaller. So if you have to draw now this graph, you'll be quickly having a graph like this. Now remember, now we are getting what? We are getting smaller and smaller as x increases. So instead, apologies for that, it's a graph like this. Guys, apologies for the background noise. I just wanted to bring you this as you guys are preparing. So it's something like this, or rather something like this. You see, remember, this is an asymptote. It doesn't touch the x-axis. But as x gets as you increase, as x increases, this graph decreases. So this is a decreasing function. All right, so they asked you here, is this an increasing or decreasing function? So you're going to say it's a what? It's a decreasing function. All right, but I spent too long there. I was just going to explain. Now determine p -1, the inverse there, the inverse of p in the form of that 2 marks. Now the inverse, remember what you do first, you let this be equal to px be equal to y, so that y is equal to 1/3x, right? And when you're doing inverse, you interchange. So x becomes what? X becomes y, y becomes x. So you're going to say x is equal to 1/3, where there is x now, it becomes y. And y is an exponent, so what you do here, you introduce logs. All right, you introduce logs. So if you introduce logs, you just put it log x is equal to log 1/3 to the power of what? To the power of y. And then from there, remember, you have to make y the subject of the formula. That's what you're doing. Now remember, with logs, you can drop this y down there. As with logarithm, so you will have here y log 1/3, see this, then is equal to log x. Now guys, from here there are many things you could have done. I think they were gonna allow you if you just did this. Let me just quickly do this. Remember, we are making y the subject, log 1/3, so that this goes, you can now divide, because this is more like that. And then even here, what you do on the left, you do on the right, log 1/3. So if you leave your answer like this, they will give you to say y is equal to log x over log 1/3. They will give you your answer, because you know it's optional. But now the proper one from here, the more proper way, whereby you are given log x is equal to y log 1/3. I think from here you need to understand, if you understand your logs, to say this log 1/3 is same as saying log x is equal to y, then you put bracket, then remember 1/3, 1 divided by 3 is same as saying log 1 minus, divided means minus log 3. I think that, I know it's 2 marks you're gonna say, but this is not worth it. And then from here you have got log what? Log x is equal to, you open that bracket, y multiplies and y multiplies. So you have got y log 1 minus y log 3. I think that. And then remember, log 1 is equal to 0. So you have got like log x is equal to y times 0. So like that. Minus y log 3. I think that. And then from here, this you could have ignored it, so that you just divide by log 3 here. Yeah, see, and then log 3. Guys, my handwriting is terrible today. I don't know what I was holding, but it's make me shake, you know. That's why it's this left hand is I'm using my left hand, you guys. Okay, no, sorry guys, I divide by negative log 3, negative, not just, remember I'm interested in y, so negative log 3, negative log 3, so that I have got, cancel that, therefore my y is equal to minus log x over log 3. See, that is that, equal to minus log in base 3 of x. This is the same, this is a base, it goes into a base there. Are you with me? So this is the more way you could see it from here, you could see it from here. Even from here you could see it, but you need to go through the steps even here just to get that. But as I say, they would have given you your mark here. I don't see anything wrong. It's just 2 marks after all. Alright, so let's look into that. That is the inverse. And then what does it say next? Write down the domain of inverse. The domain, remember, domain are the x values. Now one thing is, when you start dealing with logs, the most important thing, it doesn't matter whether you're working from this one here. When you start dealing with logs or you're working from this one, there is no log of a negative. For example, if I take a calculator and say log 0, for example, already it's an error. You see, log 0 is an error. So you start from log 1, so the x values can only be positive, you see. So here the domain, meaning the x values, means x must be greater than 0. That's why it's just 1 mark. You can't have anything less than 0. 0 is not part of it, so you can't put equal to. That becomes what? That becomes your domain, the x values. Now write down the equation of the what? The asymptote of p px minus 5. I think the p of x is the original of this graph, and I think we did draw it. A quick sketch as a reminder. I said this graph is more like looking, if you had it like this graph was more like looking like this. If you draw this graph, it was more like looking like this. Alright, it was more like that. Of course, it mustn't look like it's curving in. So this graph is more like looking like this. So now if you say to me, and by the way, this is the asymptote here, this value, the x-axis, this is the asymptote here. So what is the asymptote here? The asymptote is x is equal to 0. But now they are saying minus is what? Where is this? Here it says p of x minus 5. So this is my p of x, by the way. This is my p, graph of p. Now if they say minus 5, what it simply means is I go to the y values here and move how many steps? 5 steps. So here, that's the new equation now, which is x is equal to minus 5, where this point is 5, that point. I think that. So what will happen is this particular graph, you're gonna take it down 5 steps. So you see that. So now that's what this is gonna happen to this graph. Let me bring it all together like this. So now when they are saying here, write down the equation of the asymptote. It's 1 mark. There is the equation. X is equal to minus 5. Alright, so guys, I hope this makes sense. And let's continue with question 4.2. It says, given this, f of x is that, write down the equation of the equations, not only one, the equations of the asymptotes of f. Now, you still remember, if they give you this kind of a graph, it's very important to know, this is a what? This is a hyperbola. Alright, it's 4 over x minus 1 plus 2. What is most important to know is this particular value with the sign. This represents the y asymptote. I'll say asymptote. And then this one represents the what? The x asymptote. Are you with me? So let me do this for now. Let me undo this. I wanted to first copy this so that I don't need to redo it. So you remember what I just did, right? It's the y asymptote and the what? The x asymptote. Let me just redo this and duplicate it down here. And then, okay, so we agree. So now with the x asymptote, what I'm going to do here, since this is the x asymptote, it will be x minus 1 equal to 0. Therefore, x is equal to, take 1 to the other side, is equal to 1. What is this one? This is the equation. Remember, write down the equations of the asymptotes. That's the first equation. And then the other one, y is equal to 2. That's why they say to write down. You don't need to work it out. You can even ignore this part. Just writing is negative, it will become positive, but it's fine to understand where it came from. Alright, so the next question is that was 2 mark. Calculate the x-intercept of f. Now what you need to know when they talk about the x-intercept, now what does the word intercept mean? Where it casts the x-axis. Remember, at that point along the x-intercept you must always know y is equal to 0. In the y-intercept, x is equal to 0. In other ways, f of x in the x-intercept, y is same as f of x is equal to 0. So that's what you do here. I'm gonna use this one. Again, I don't want to keep writing this, so let me duplicate it and keep taking it down. So if this one is equal to what? Is equal to 0, f of x is equal to 0 here on the what? On the x asymptote. So what will I have? I will have 4 over x minus 1 plus 2 is equal to 0. Guys, you're solving for x here. Simple thing, take 2 to the other side. So you've got 4 over x minus 1 is equal to negative 2. What do you do from here? Simple thing, multiply by that fraction because you don't want this fraction, right? So you multiply by what? Everything by x minus 1. What you do on the left, you do on the right. X minus 1. You see? So that fraction goes. Are you seeing that? So from here, you have got 4 is equal to, now open up that bracket, minus 2 times x minus 2 times minus 1, which is negative 2x minus 2 times minus 1 is plus 2. Again, we are solving for x. Take the positive 2 to 4. It becomes minus 2 is equal to negative 2x. Now 4 minus 2 is 2 is equal to minus 2x. You divide by negative 2 on both sides. So what is your x? X is equal to the 2 into negative 2 into 2. It's negative 1. There is the answer. X is equal to what? Minus 1. So what was that? That was the x what did they say? Calculate the x-intercept. So, but if you're to write it in coordinate form, because that's what we need as an intercept, x is negative 1, y is 0. Now these are coordinates of the intercept. It's more important like that. Even if you said x is equal to minus 1, it was going to be fine because they never really specified it as coordinate form. And then say sketch the graph of f, label all asymptotes. Now look where they are tricking you. They are saying label all the asymptotes, which we did here, and indicate the intercepts with the x's. You see, they did say find the x-intercept, you see, but here they say all the intercepts, which meaning they are in a way cunning. That's why it's 4 marks. They wanted to find the x-intercept. Sorry, not the x, because we did the other one, the y-intercept now, because 4.2.2 is the x, so this one is the y-intercept. You need it in this particular question. Don't forget, in the y-intercept, x is equal to 0. So we're going to start from there, looking at the y-intercept. That's why I'm using this. So here, you'll be having f of 0 is equal to, remember, here in the y-intercept, x is equal to 0. Alright, so you've got 4 over 0 minus 1 plus 2. Guys, I apologize again for the background noise. I just wanted to bring this to you. If you do this with the calculator, minus 4 plus 2 is equal to negative 2. So what are the coordinates here? When x is 0, y is negative 2. So these points are all important for the sketching of your graph. And then remember, you are dealing with, when they say sketch, guys, it's a sketch. You are dealing with a hyperbola. So when I'm sketching it, it will have, very important, first things first, do your housekeeping rules. This becomes your y-axis, label them, label those. X and y is the housekeeping with the arrows. That's the most important thing to start with. Then from there, let's identify the sketch, our asymptotes. We said x is equal to 1, y is equal to 2. We need to draw those. So I come here and I'm going to draw the asymptotes of x is equal to 1. So I just gonna make it like this. Say this is my x is equal to 1. But because it's an asymptote, it's very important to do it with the what? Dotted line. It's very important. Have it in a dotted line to show that this is an asymptote. And the other one, y is equal to 2. You also do the same thing. You do that. That's y is equal to 2. But what you do? Do a dotted line. Alright. Okay, so you need to also label them. Y is equal to 2 and then x is equal to 1. Okay, those are very important things to do, because if you don't label them, they will penalize you, because they said what? Label all asymptotes and indicate the intercepts with the x's. Now let's go to the intercepts. The first one was -1, 0. Identify -1. Okay, by the way, we are sketching. So if you are sketching, remember the type of sketch. Now let me just bring this to your attention again. If you're given a f of x, the general form is equal to a over x, and then after that you've got g of x, okay, is equal to minus a over x. Now how does this look? Remember, if it's like positive, it's skewed. Okay, if it's positive, this is what you do. If it's positive, it's in quadrant 1, because this is quadrant 1 and this is quadrant 3. So the graph is in quadrant 1 and 3. It means it's positive. If it's negative, you do the same. The graph is in quadrant what? The graph is in quadrant 2 and 4. So when you draw that graph, it will be like this and it will be like this. But the good part is this graph was positive. You see, f of x is positive. Now it's a positive graph, meaning it's in quadrant 1 and 3. And when you draw now this graph, your drawing will be like this. So you've got that as your graph. Okay, let me not. Remember, the asymptotes are important. And you've got this one as your graph. Okay, I'm not liking it. I don't like what I did, but let me try. You must ensure that you are curving. Okay, let me leave it like that. Now, then there is that point, hence they call them the what? There, -1 and 0. The intercepts, remember, with the x's. There is -1 and 0. Actually, this graph is wrong. Sorry. This graph is wrong. That one is fine, but look at it. Remember, the asymptote is not the y-axis. Actually, it's supposed to be like this. Some of you picked it up. It's supposed to be like this. I must not touch that dashed line. Me, I was avoiding now the other one, but it's this one. All right, that is it. So that I've got that point and this point. These are the intercepts. So these are the x-intercepts. Now for the x-intercepts, remember, this is the x-axis. That's your -1 and 0. It's negative. And the other one, it's what? 0 and -2. They said you must indicate them. So this one is a 0, -2. You can put -2 here, it's good. You can put -1 here, it's also part of indicating. But the coordinates are also important. Guys, that's the sketching there. Questions? If so, I hope you understand. Next one says, use your graph to determine the values of x for which this one, 4 over x minus 1, is greater than or equal to -2. You see, they're playing with you here. Let me write this 4 over x minus 1. Let me write that. I want it closer to the graph. They are saying 4 over x minus 1 is greater than or equal to 4 over x minus 1 is greater than or equal to -2. You see, they always give you something just to confuse you a bit, but it mustn't confuse you. Now look, if I take this back, I will have 4 over x minus 1 plus 2 is greater than or equal to 0. Guess what? This is actually our graph. By the way, something is wrong here. What is wrong with this? I forgot to label my graph. This is the graph of what? This is the graph of f, please. That is also important. I forgot. You need to label the graph, you know. Labeling is part of it. So don't just draw a graph without a name. What if there were 2 graphs in? That's why they said show the y and x, also label the one. But now look at this. What is this scenario that I have now here? This one. What is this? If you go, it's a 4 over x minus 1 plus 2. There it is. 4 over x minus 1 plus 2. This is my f of x. So in other ways, they are saying here, if I put f of x it means f of x, because this represents f of x, is greater than or equal to 0. So they are saying, let's read now the question in understanding. Use your graph to determine the values of x for which f of x is greater than 0. So they're saying I must use my graph to find the place where f of x, where that graph is greater than or equal to 0. Now the cutoff line here is this one. Greater than 0, this is 0. That's where here I have got what? My x is equal to 0. So if it's greater than, they are saying look up above this line. And where is it above this line? It starts from there. You see? And where does it go? You see this graph is going this direction. Look, that's where it's going. This part, let me mark it like this. All this part, that's where it's above the line. It means it's greater than 0. This is greater than 0. Okay. Now, what is this point? Remember, x is minus 1. So here, how to write your answer? You are going to say x is this direction, guys, on your Cartesian plane is less. It's the less sign, which is this one. So x is less than what? Minus 1. But they say equal to, because it's f of x is greater than or equal to. So you also include x is less than or equal to minus 1. That's the first answer. The second one, there is a part where it's above the graph, which is also this one. Look at this. This side, this part. See? It's above. It's above. So where does it start from? Again, x is equal to 1. So here we are going to have x. You see, it's going from 1 and going this direction, which is the greater than, which is more. You see, greater than. So here x, let me just okay, it's fine. X is greater than or equal to what? Equal to 1. This is the second answer. So those are the answers that they needed. They needed this one and they needed that one. X is less than minus 1, x is greater than minus 1. In other ways, they are trying to come up with this is the point here. This point is the one that is not included. See this center point? It's more like left out. Are you with me? Alright, let's look at the next part, the last question here. It says determine the equation of the axis of symmetry of f of x minus 2 that has a negative gradient, the axis of symmetry. Now, if you remember, let's come back again. What was I drawing? Yes, I was drawing this graph, the foundational graphs, the original graphs. Now, these graphs, if I was to draw them, this one, there is this line, and there is that line. These lines are all passing through the center. Now this has got the gradient here is equal to minus 1. Always know, and here the gradient is equal to 1. So this is called positive gradient, positive m, and the other one is negative m, negative gradient. Alright, so even here it will be the same. This is the line of symmetry, and that is the line of symmetry. The one is negative m, is negative 1, not just negative m there. Here m is equal to 1, positive 1. So it maintains even here. When you are to have your line of symmetry, what must I use? Let me use a different color here, my yellow. If I'm to have a line of symmetry, now it will pass through that midpoint where these two lines are meeting. Now what is that point there? Remember, x is equal to coordinates, x is 1, and then this side y is 2. See, that is that coordinate. So now the interesting part is, you know, the point is m is equal to negative 1, by the way, the gradient, and the point is 1 and 2. From here you can find the equation of a line using y is equal to mx plus c. Alright, so what do you do from here? You are going to say y is 2 to get the c now is equal to m is minus 1, x is 1 plus c. See where I'm driving it here. So now take negative 1 to the side, it will be 2 plus 1, because minus 1 times 1 is negative 1, is equal to c. 3 is equal to c. So the equation, the question was find. Alright, okay, I think I'm missing it. Okay, determine the equation of the axis of symmetry of which, yes, that's correct actually, because it's oh no, that's not correct. It says determine the equation of the x of symmetry of fx minus 2 that is a negative gradient. So this is the one that is a negative gradient. So what I calculated here, careful, is the original, where the equation of a line was going to be y is equal to m minus 1 x plus 3. See, so negative x plus 3. But this is not the answer. Please, this is not the answer. I made an error. So what you do, they are saying you are given f of x minus 2. Now you must understand, when you're saying minus 2 here in the bracket, what transformation are you having? This is you are moving here, we are moving the graph. Now if it's along the x, you see it's within the x here, so it's horizontal, or I can say along the x-axis, that's what you're doing here. So you're translating this graph along the x-axis, but to which direction? Is it left or right? If you say minus, it goes to the right, so it goes this direction, the graph goes this direction instead. So which means, how many steps does it go to the right? It goes to the right. These are the steps, 2 steps. All right, so these are the steps that the graph will move. The negative sign shows the direction. If it's negative, you go to the right. If it was positive, you go to the left. So it means this particular point 1, 2. So you say, okay, I had a point 1, 2. Now what is going to be the new point when this graph is moved 2 steps to the right? 2 steps. What will be the new point? Remember, the y will not change. It's only the x that is changing because it's horizontal. So horizontally it's like this. If I can try to give you a scenario, but I'm not going to be able to do it on both graphs, but it's like I'm pulling this graph. It's like I'm pulling this line like this horizontally, so the y won't change, only the x will be changing. You see, the x will be increasing. Are you with me? So if I can use this graph, it will be more like I'm saying like this. This is the graph. It will be moving horizontal like this. So that's what is happening. So when I'm moving it horizontally, don't forget the y is not going to change. It's only the x. So this x is the one that will move 2 steps here to the right. So if it's 1, it will become what? It will become 1, 2, it will become 3, because you're saying 1 plus 2. But the y value won't change. It's like this. Then you are looking at the equation of this new line. Then your m here doesn't change. The gradient m is still minus 1. Then you can say y is mx plus c. So I was too early to apply it here because I didn't move. I used 1, 2, the original. But you are supposed to use instead 3, 2. Then you're going to say this is your x, this is your y. That's why you say 2 is equal to m, which is minus 1, 3 plus c. Then take negative 3 to this side, is 2 plus 3 is equal to c, which is 5 is equal to c. Are you getting it? Now the equation of a line is y is equal to m, which is negative x, mx, negative 1x plus 5. Then that becomes your answer. You can put your negative 1 if you want, but it's not a must. Okay, so guys, this is what I was talking about in relation to this particular question. All right, so now how many marks was this? 18 marks. Not bad. I think you could have done it. I don't see a challenge there, but yeah, it was. They wanted to make this one a little bit higher order here. They wanted to make this question a little bit higher order. So guys, I'm going to I need to go to this video, this one, but I have to pause because I think this video is now long. So join me in the next video where I'm going to just continue doing question number 5. So don't lose me now. Don't lose me. Watch this video, practice it on your own. Remember, this is a 24-minute lesson, meaning just give yourself around 24 minutes. Watch and then give yourself a break. Even if it's 15 minutes, it's good, because your mind can only absorb up to 24 minutes maximum. Whatever you try to do after that, well, you will be almost wasting time. So study tip number 1, try to watch and study in 24 minutes. Give yourself a break. 15-20 minutes, give yourself a break. It might look like you're distracted, but this is the way to go. You will gain more than someone who says, I want to sit for 2 hours undisturbed without standing up. Trust me, that person, if you can check the amount of work done, you will discover that the first 24 minutes is the most effective. The rest, they were just like a graph. It's an exponential graph, by the way. So it's like this when you study continuously. Let's say this was now 2 hours studying. So here, I'll take it in 24 minutes. So this is 24 minutes. This is 48 minutes. This is what? Plus 12 again. 48. This is 72, I think. So now, a person who sits same time studying, this is concentration here. You know, you are concentrating. So it starts being high, your concentration high, but the time, this is time, start dropping. After 24 minutes, you drop. If you continue for 2 hours, you see your graph is going down like this. But what about someone who does breaks? So what happens is when you're doing breaks, your concentration is going down. It's going down like the first 24 minutes is the same, all of you. It's going down. Then you do take a break. It goes up. You start again. It goes down. Sorry about this. It goes down. You start again. You see, it goes down. You see, if you continue, look at the end. This person is still having this amount of concentration here. He's still concentrating well. But you, look at it. If you're sitting for 24 hours, it's almost zero concentration. But this one is still having almost half of it. Study tip. I just wanted to show you, maths is everywhere. Alright guys, let's join me again in the next lesson. By the way, I know I said don't waste time, but join me where I'm going to show you this. Thank you.